Hello viewers, today we'll talk about synchronous and asynchronous programming. We'll see what is the difference between synchronous programming versus asynchronous programs. We'll see when to use a synchronous program and when to use asynchronous program. So let's get started on synchronous versus asynchronous slides today. So it is also called async versus sync. So here we have, in case of async, we have request 1, request 2 can be processed uh, together. We don't need to wait for request 1 to get completed and then request 2 will start. But in case of synchronous processing, request 1 will complete, then request 2 will start. So request 2 have to wait for the response from request 1, but which is not the case with async. With async you can achieve parallel programming as well. So what is synchronous programming? So in programming style, synchronous program allocates a single thread to handle a request or complete a task. Since synchronous operation happens one at a time, a painstakingly long task like a database query will block all the other threads in meantime, while asynchronous operation can run multiple tasks concurrently on a single thread. Synchronous program have a task queue where every other task remains idle while the first is completed. By definition, synchronous means connected or dependent. In essence, synchronous computation is tightly coupled. For reactive system, when programs work best when they react to environmental input, synchronous programs can be useful. Synchronous program uses blocking I/O operation in which each operation has to run before the next is executed. Generally, computers are fast, so synchronous communication is not necessarily disadvantageous. However, in real life, non-technical application, this would be equivalent for your waiter refusing to bring out any of the dishes you ordered until each and every dish were fully prepared. So you can see here, in case of synchronous execution, request 1 is given, and then when the response for request 1 is served, then request 2 starts, and when the response from request 2 ends, then request 3 will start executing one at a time and in order as well. So what is the benefit of doing this? So synchronous programming is well supported amongst all the programming languages. Developers do not have to worry about whether it is possible to code synchronous programming or not. But in case of asynchronous, developer had to check how to see the how to code the asynchronous programs. Plus, writing synchronous operation program is objectively easier than writing asynchronous programs. In utilizing a blocking I/O architecture, you can save time in software development process and run tests with fewer complications. Search engine finds it easier to crawl for web pages that makes use of traditional synchronous architecture. For marketers who depend on on search engine optimization to build their reputation and brand awareness, this is an appreciable advantage. Let's see what is asynchronous programming. So asynchronous programming relies on a non-blocking input and output program. So this signifies that an asynchronous program does not execute operation in a hierarchical or sequential order. This is the main difference between synchronous and asynchronous. This is non-hierarchical or non-sequential order. The resulting parallelization means an asynchronous program can take on multiple requests simultaneously and independently. When one request fails, it has no effect on other requests, and the program can move to other tasks before finishing the last. In software development, an advantage of this kind is also called loose coupling. A loosely coupled communication and/or programming allows for decentralized application. In this diagram, you can see multiple requests can be sent together, and response you can receive from any depends on the processing speed or depends on the task. It is non-synchronous in order. It is not hierarchical as well, and order is not maintained in case of asynchronous programming. What is asynchronous programming all about? So fewer dependencies lead to higher fault tolerance and increased flexibility. For businesses that prioritize getting things done, asynchronous programming can be a fundamental building block in meeting project requirements. Imagine a non-technical example of how asynchronous communication would like in real-world scenario. As an illustration, envision you are in a restaurant. Your waiter just has taken multiple orders at your table and brings out the appetizer as soon as it is ready, instead of waiting for you to main entry to be prepared as well. Not only is this simplify efficient services, but it is an extemporary demonstration of non-blocking I/O or asynchronous architecture. So what are the benefits of doing this? So in comparing synchronous and asynchronous programming, so asynchronous program improves user experience in a variety of ways. First, all the scripts of a program or a web page can load at one time, resulting in better responsiveness and decreased page load delays. And the failure of a thread has no consequence on the availability of the other threads to run or render. Therefore, there is more availability overall with the asynchronous applications. In practice, asynchronous programming require writing callback function in line with the error that may occur and disrupt the program. These callbacks instruct the machine to move past the error and run the next task. This also gives programmers the opportunity to write a personalized error message. As a result, error do not mean that your program altogether fails or to run. You just get a nice note while all the other features of the program work just fine. So here you can see in this diagram, in case of synchronous, request 1 is served first. When the response is received for request 1, then request 2 gets processed. But in case of asynchronous programming, request 1 and request 2 both can be processed together, and we can get the response for request 1 and 2 together. Here today in computer we have more than one code, and so each code can work independently in case of asynchronous programs. So use case of synchronous versus asynchronous. For example, if you want to download a file from the internet, you might use a synchronous function to do that, but it will block your thread until the file finishes downloading. This can make your application unresponsive to any user input. Instead, you would download the file in background using asynchronous method. In this case, the download function returns immediately and program execution continues normally. All the download operations are done in the background, and your program will be notified when it is finished. When you execute something synchronously, you wait for it to finish before moving on to another task. When you execute something asynchronously, you can move on to another task before it finishes the first. So synchronous execution means the execution happens in a series A, B, C, D, one by one. If you are calling method A will run first, and then when the A finishes, then B will start. With asynchronous execution, you can start with A and then A can go in background, and we don't need to wait for A to finish. B can start parallelly. The biggest contribution that asynchronous program provide is enhanced throughput. Throughput refers to the deliverables a product or company can produce within a specified time. As established, computers are fast. Thus, synchronous programming is not a time-consuming, or as you might imagine. If you merely wish to develop a front-end application or execute a basic central process function, then asynchronous programming is way out of bounds. So due to parallel execution, the asynchronous task will finish first, whereas in case of synchronous, if multiple tasks are there, then to finish all the tasks it will take more time, that you can see in this diagram here. So user interface, in case of what is the use of synchronous? So first use case is user interface. A user interface designed are typically synchronous. Since UI are aspects where human and computer interact, it is ideal for them to replicate the communication standard and practice humans are familiar with. Humans expect an immediate response when they interact with the computer. HTTP APIs is another use case for synchronous programming. HTTP APIs pass request and response in synchronous fashion. Client programs sending HTTP request usually expects a faster answer from the web server. Use case of asynchronous is batch processing. So it is a data processing method to handle large amount of data asynchronously. With asynchronous batch processing, large batch of data are processed as scheduled time to avoid blocking computing resources. Second is long-running tasks such as fulfilling an order placed on e-commerce site are best handled asynchronously. There is no need to block resources while the task is executed. So in summary, we can say synchronous and asynchronous, also known as sync and async, are two types of programming model. At an abstract level, programming model define how software is designed and executed. The basic programming model are synchronous, but asynchronous models are critical for performance reason and to more efficiently use computing resources. Programming languages usually have built-in primitive to deal with asynchronous programming. Asynchronous programming is a style of programming in which the execution of a task is not guaranteed to occur in a specific order. This contrasts with the synchronous programming where all the code execution is guaranteed to happen in a specific order. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.